Good morning, one and all. Today, me, Gaurav, and my teammates Janani, Mihir, and Preksha are going to present our reel on the topic supercapacitor and advanced polymer electrode. Okay, next slide. Okay, a supercapacitor, also known as an ultracapacitor or electric double layer capacitor, is an advanced energy storage device that bridges the gap between traditional capacitor and batteries. Unlike regular capacitors that store energy through the separation of charges on their plate, supercapacitor utilizes a unique mechanism involving electric double layers at the interface between the electrode material and the electrolyte. Electrode also plays an important role in this process. Usually they are porous carbon, which has very high surface area, allowing for storage of more number of charges in smaller space. Now, what sets supercapacitor apart is their ability to store and deliver energy quickly, making them excellent for applications requiring high power burst. Now, they exhibit a high power density, allowing for rapid charging and discharging. Hence, they can endure a large number of charges and discharge cycles without significant degradation, unlike traditional batteries. Next slide. Okay. Now, let us imagine an EDLC as a special kind of energy storage device. It works by using two main parts, electrodes and an electrolyte. Now, due to the nature of porous carbon structure, the electrodes have a lot of tiny spaces on their surfaces where something called an electric double layer forms. This double layer is like a separation of positive and negative charges at the surface. Now, when we want to store energy, we apply voltage to the EDLC. This makes positive ions from the electrolytes stick to the negative electrode and the negative ions stick to the positive electrode. It's like a magnetic pull that holds the charges in place. Now, when we want to use that stored energy, like a quick burst of power, for example, we let go of that voltage. The charges are released quickly from the electrodes back into the electrolytes. This quick release and uptake of the charges creates a flow of electricity, giving us the energy we stored. Now, the cool thing about this EDLC is that they can charge and discharge really quickly. This makes them great for devices that need sudden burst of power, like camera or some hybrid cars. They can also do this charging and discharging lots of time without wearing out quickly. So basically, an EDLC stores energy by arranging charges at its electrode surfaces, and when we need that energy, it is released uh, through quick bursts of power. So it's like a super fast battery that's really good at delivering energy in short bursts. Next slide. Now, one might wonder, why do we need supercapacitors? Now, let us imagine the real world scenario where we have devices that need a lot of power, but they also need that power in an instant. Regular batteries are great at storing energy, but they can take a while to charge up and release that energy very slowly. This can be a problem for things like electric cars that need to accelerate quickly or for devices that need to capture energy from regenerative braking. So this is where supercapacitors come in. Supercapacitors are designed to store a lot of energy really quickly and release it just as fast. They can charge up in a matter of seconds and then give a powerful burst of energy when needed. Think about your smartphone, for example. You probably experienced the moment when you need to go out, and the charge is not there. Hence, you need charge in a short period of time. Supercapacitor in your phone can do this job by quickly store up the energy and give you a quick boost, so you are not left waiting around. Not only that, but supercapacitors also great devices that need charge over and over and without wearing out. So we can charge it indefinitely without their affecting their performances. But traditional batteries, on the other hand, degrade very fastly with constant charging and discharging. And supercapacitor can handle this repetitive action without losing their effectiveness. So we need supercapacitor because they are like speedsters of energy storage. They provide quick burst of power. They can charge and discharge rapidly, and they're reliable for the long run. They're changing the way we think about energy storages, making our gadgets faster, more efficient, and more versatile. Next slide.
So as a part of phase two, we have made a supercapacitor, a small scale supercapacitor in a laboratory scale. So first we'll discuss what materials of construction we have used to make the supercapacitor. So as you can see, first of all, we have used the stainless steel metal mesh, which acts as a current collector. And the electrode material that we have used is activated carbon due to its high surface area offered. The separator that we have used in supercapacitor is the available filter paper, which prevents physical contact between electrodes. The electrode used in this setup is sodium hydroxide, that is 1 molar, and is chosen because sodium is a relatively small ion and has increased ionic mobility. And we have enclosed the whole setup in a tic tac box. So systematically, if we have to discuss the fabrication steps, first of all, we start off with preparing the electrodes. So as you can see in figure A, we have taken the dimension of the box and cut the steel mesh accordingly, and we have a protrusion so that it aids in contact. After that, we add adhesive, that is Fevicol in our case, and then we go to the activated carbon. We had left it to dry for about an hour, and then the excess of the activated carbon was removed. After that, our electrode is ready. After that, in an alternating fashion, we wrap these electrodes with filter paper, that is a separator. Two of them are positive polarity electrodes, and two of them are negative polarity. So the positive polarity electrodes, we take them together, and the negative polarity, we take them together, and we get two counter electrodes as shown in figure C. And finally, we take the whole setup, put it in the box, and after sealing, we inject it with our electrolyte, that is NaOH, 1 molar. After that, our supercapacitor is ready. So we went another step ahead and did the testing in our physics laboratory. So as a first step, first we applied a voltage of 2 volt, and the output given by a supercapacitor after charging was about 1.09 volt. When we increase the voltage by the direct current battery eliminator to 4 volts, we got a power voltage output of 3.85 volts given by a supercapacitor, and the discharge after this voltage was enough to light an LED lamp, which shows that it has good potential for powering small devices.
Polymer electrode. Polymer electrodes refer to the electrodes that are made from conducting polymer. These materials are a class of materials that combine both properties of polymers and conductive materials. These materials have gained a significant attention in various fields due to their unique combination of electrical conductivity, mechanical flexibility, and tunable properties. Furthermore, polymer electrodes can exhibit high specific capacitance, allowing for efficient charge storage and delivery. One prominent class of polymer electrodes for supercapacitors is conducting polymers, such as polyaniline, polypyrrole, and polyethylene dioxythiophene. These polymers possess unique ability to undergo redox reactions so that they can store energy through doping and de-doping process. Their high conductivity coupled along with their electrochemical reversibility makes them ideal for supercapacitor applications. To further optimize the performance of polymer electrodes, researchers have explored composite systems. By combining polymers with other materials like carbon nanotubes, carbon nanoparticles, or metal oxides, composite electrodes will acquire the unique properties of each component. These hybrid structures exhibit improved electrical conductivity, enhanced surface area, and optimized charge transport, resulting in enhanced overall electrochemical performance. Pani is a polyaniline. It is a conductive polymer that has been widely studied as an electrode material for supercapacitors. It is used in energy storage and conversion. It is used in capacitors, rechargeable batteries, and also in fuel cells. When they are used for supercapacitor, it acts as the active electrode material, which indeed acts as a charge carrier during the redox reaction. Why we have selected this electrode? Because it exhibits both pseudocapacitive and double layer capacitance behavior, which makes it suitable for energy storage applications. This dualistic characters enables Pani to overcome the limitations of conventional capacitor, double layer capacitors, yielding higher capacitance values. And also this has high capacitance up to 600 farad per gram. This property signifies the exceptional ability to store and deliver electrical energy, ensuring optimal performance in electrical energy storage applications like supercapacitors. The second property is pseudocapacitance. In pseudocapacitive properties, this polymer enables to store and release charge through Faraday reactions at electrode and electrolyte interface. This distinctive feature enhances the charge storage capacity and differentiates it from conventional double layer capacitor, contributing to the energy density and efficient charge and discharge cycles. The next one is high conductivity. With high electrical conductivity of 100 Siemens per centimeter, this polyaniline facilitates rapid charge transport within the electrodes. And the and it is flexible and processable, so that it can be used in wearable electronics and many other devices which are bendable. The most advantage of polyaniline is that it is very affordable, and it is the raw materials used are readily available, and they are cost effective, which contributes to the economic viability for large scale production and commercialization. We can prepare polyaniline electrode through various processes. One of the most common processes is chemical oxidative polymerization approach. In this method, we can use potassium dichromate, sulfuric acid, and polyaniline to make the polymer. We had taken 18.7 gram of potassium chromate in a beaker. So this acts as an oxidating agent which initiates the polymerization process. When the aniline, the monomer, comes into contact with this, it undergoes oxidation, resulting in the formation of polyaniline. This crucial step provides the necessary reactive environment for the polymerization to begin. The next step is adding aniline into the solution. These are the monomers. When they are added into the solution, they start linking to each other and form backbone of polyaniline. This kickstarts the growth of polymer chain, setting the stage for subsequent reactions. The next step is addition of sulfuric acid. So this is added for primarily two reasons. The first reason is this acid enhances the electrical conductivity of the polymer. This is done by including the electrons in the polymer. It enhances the flow of electron in the polymer. Secondly, sulfuric acid acts as an acid catalyst, speeding up the oxidation and polymerization reaction between aniline and potassium chromate. This accelerates the overall reaction rate and ensures efficient formation of pani. Then the reaction mixture was stirred for 4 hours, and then the precipitate was filtered, and then it was coated in the mesh. The figure A represents the mesh covered with polymer electrode, figure B is the dry powder, and figure C is the wet polymer.
Due to huge advantage of supercapacitors, application spans over a wide range from basic electronic gadgets like LEDs to defense and medical devices. It is widely used as a stopping and starting engines, so more quickly and efficiently than batteries. This can save fuel and reduce emission. So they are also used in powering hybrid and electric vehicles. Um, to store energy in hybrid vehicles and electric vehicles, this allows the vehicles to accelerate more quickly and improve fuel efficiency to deliver high power. It's also used in industrial and electronic applications, in regenerative braking to release the power in acceleration, lightweight power supplies for small aircrafts. It's also used to extend range and battery life in hybrid electric vehicles. Then it's also used in providing backup power. Supercapacitors can be used to provide backup power during power cutoffs, so which keep critical systems such as hospitals and data centers running. So it's also used to filter noises from electronic signals. This can improve the quality of audio and video recordings. So the common application of supercapacitor is to recharge devices such as laptops and smartphones. This can be done quickly and easily due to its high power density without the need of a battery. These are the references we refer to, and thank you.